Hello students. After polyesters, the next category of polymers is resins. As in each group there is a common monomer. In resins, the common monomer is formaldehyde, that is HCHO, which is an aldehyde group, or it can be written as CH2O. In HCHO, this bond is the reactive bond, this pi bond is the reactive bond, and as it is a heteroatomic bond, it leads to heterolysis, leading to formation of positive and negative charge after the lysis. Let's take an example. Let's consider an example of NH. This bond is also a heteroatomic bond. After lysis, it will lead to formation of nitrogen negative and hydrogen positive part. This formaldehyde will react with this group. This positive will attach at the negative part and this negative will attach at this positive part, and this leads to N. This N is attached to carbon, which is directly attached to two more hydrogens, and which is again attached to oxygen, which then joins hydrogen. This is the base for this group. Basically, it seems like this formaldehyde CH2O adjusts itself between nitrogen and hydrogen. So this is the property of this formaldehyde. It adjusts itself between hydrogen and one of the heteroatoms or carbon, whichever is taking part in the reaction. We'll discuss four resins here. First is urea formaldehyde resin. Second is Nolec. Third is Bakelite. And fourth one is melamine polymer. Let's start with urea formaldehyde resin. The two monomers here are urea and formaldehyde. So the first is urea formaldehyde resin. So the first monomer is urea. Urea is NH2, CO, NH2. And second monomer is formaldehyde. These two monomers combine to form a unit which on repetition forms the polymer. So when these two combine, let's recall the property. This formaldehyde will adjust itself between a heteroatom and hydrogen. So it will adjust itself here and leads to formation of this unit CO, N, H and CH2O, H. Now this is the repeating unit, and after condensation reaction or elimination of water, OH from this side and H from this side, OH of this molecule, this monomer, and H of another one, the next one. Similarly, H of this and OH of the previous monomer leads to formation of the polymer, and the polymer is urea formaldehyde resin. So this is the first resin, and this is urea, first monomer, and this is formaldehyde, second monomer, and this polymer is urea formaldehyde resin. Next resin is Nolec. The two monomers are phenol and formaldehyde. Phenol is hydroxyl group attached to benzene. This is phenol, and formaldehyde is CH2O. Here at each carbon there is one hydrogen attached, which is not represented in the structure, and the property of formaldehyde is to get adjust itself between the carbon and hydrogen. So the repeating unit formed after combination of these two monomers is this unit. This is the repeating unit for Novak, and with elimination of OH from this side and hydrogen of this leads to formation of the polymer, and that polymer is Novak. This is Novak. The next polymer is bakelite, and bakelite basically is cross-linked Novak. So when formaldehyde is used in excess, phenol and formaldehyde, again the monomers are the same. And formaldehyde is used in excess, it gets attached not only at ortho position but also at para position. And the repeating unit so formed is this CH2OH. This formaldehyde gets attached at ortho and one at para. And with elimination of water molecule, OH from this, hydrogen from this, OH of this, and hydrogen from the another which is present at the bottom, leads to a cross-linked structure, and this cross-linked structure is bakelite. So this is bakelite. And the last resin is melamine polymer, and the monomers are melamine and formaldehyde. Melamine is a benzene-like structure having alternate carbon-nitrogen. So nitrogen, carbon, nitrogen, carbon, carbon, nitrogen. Alternate carbon-nitrogen and alternate single double bond. So the valencies of nitrogen get fulfilled, and carbon is attached to an amine group. Each carbon is attached to an NH2 group. This is melamine, and formaldehyde is CH2O. Again, it will adjust between nitrogen and hydrogen at two positions, at this position and this position. So it will lead to formation of the repeating unit. This is the repeating unit after formaldehyde gets attached to melamine. One of the groups will remain free from formaldehyde. The concentration of formaldehyde is taken such that it will attach at two positions. And with the elimination of water molecule, OH from this side and H from this side, OH from this side and H from another one, it leads to formation of the polymer, that is melamine polymer. CH2. Again, melamine polymer is a cross-linked polymer where chains are attached through this bond. So this is melamine polymer, the last resin.